Okay, we're going to get a little more work here on quadratics and kind of get into finding some of our roots, looking at the openings and some maximum minimum stuff. So here's a couple of things that we're going to be focusing on here. Okay, if our a value is positive, that means this thing opens up. So let me draw you what that means. So if I had an equation like y equals 4x squared plus bx, or instead of bx, let's use an actual number, plus 6x plus 2. That parabola is going to look something like that. Now, we know that because this is our a value in our graph. Remember, our equation is y equals ax squared plus bx plus c. So our a is whatever is attached to our x squared term. So our a value is 4. Since it is 4, it's positive, we know this thing opens up. If it opens up, take a look at our vertex point. Our vertex point, is that the lowest or highest point on our graph? Well, it's definitely the lowest. It's like the bottom of our valley here because every other point is bigger than it, which means this thing has a minimum. So it has a minimum if it opens up. And I kind of summarized that all for you right here. A is positive, opens up, it's got a minimum. Now, if a was negative, so I had y equals negative 4x squared plus 2x plus 1, now I might have something that looks like that. And now take a look at my vertex point. Is that a maximum or a minimum? Well, that's kind of the top of our cliff. That's a max value, and it opens down. How did I know all that? Well, I just have to take a look at this. This is negative. Our a value was negative 4. And I summarized that for you right here. Our a value is negative. Our parabola is going to open down, which means it has a maximum. So let's try to pick that apart. Here, what's our a value? It is 5. What does that mean about our opening? If it's positive, it opens up. If it opens up, what does it have? A max or a minimum? Well, of course it has a minimum. Here, what's our a value? Well, we can't really see it, but it's an imaginary 1. Same thing, it's positive, it's going to open up. Does it have a maximum or a minimum? It has a minimum. And our negative 3. So here our a value is negative 3, that's what's connected to it. This is going to open down, and just like we showed over here and up here, it has a maximum value if it opens down. Okay, one of the most important things we will do is going to be finding the zeros of a quadratic relation. Okay, we're not going to spend too much time using what's called a difference of squares in this course. So we're going to skip over most of this. But this skill, finding the zeros of a quadratic relation, will always involve factoring. I'm going to show you a different way of trying to make this difference of squares happen here. So instead of using all these shortcut methods, which we can get into later, we can treat this x squared minus 25 as kind of that simple trinomial. Remember we had like that x squared plus 2x minus 25? Well, I could say, yeah, we know how to factor that. But what are we missing? Here we have a middle term. Here we don't. So if I told you factor this, what would you do? You would say, okay, well, you need to find two numbers that multiply to 25 and two numbers that add to the middle number, which is 2. So let's do the same thing over here. We're going to find two numbers that multiply to 25 and two numbers which add to our middle term, which is what? Well, it's not there. What's another way of saying not there? That means 0. And that really helps us out. Because as soon as you see that there's no middle term there, you should have alarm bells going off in your head, because if we have to have something that adds to 0, we need to have the same number. We need to have the same number positive as negative. And I'll show you what I mean right now. What two numbers multiply to 25? Well, 5 and 5 are going to multiply to 25. Oops, I forgot. It's negative. I should have put a negative sign there. So 5 and 5 are going to multiply to negative 25. So all I need to do, make one of those things negative. So negative 5 times positive 5 equals negative 25. That's true. And negative 5 plus positive 5 equals 0. Perfect. So we found our two numbers that easy. X minus 5 x plus 5. Perfect. For this one, we'll do the same thing. We don't have a middle term again, so which two numbers are going to multiply to our last term, negative 16, and which two numbers are going to add to our middle term, which we don't see, so it's 0. Remember, if you see 0, you need the same number. So what same number multiplies to 16? Well, we're going to need a 4 and a 4, but it's negative 16, so one of our numbers needs to be negative. So we're going to have negative 4 times positive 4 gives us negative 16, and negative 4 plus positive 4 gives us 0. So our two numbers are x minus 4 and x plus 4. Excellent. All right, looking good. So here what we're going to take a look at is our graph passes through the point 221, but we actually don't have the equation for it. We just have this stuff over here. So what we can do is if we have our formula y equals ax squared plus 5, well, just like we did back a couple units ago, we said, okay, this is our x coordinate, this is our y coordinate. Why don't we use that to our advantage? Because we can actually take that, substitute it in, and then make something happen here for us, which would be very, very helpful. So what we are going to do here is substitute that in. We'll have 21 equals a, and then x squared, which is 2 squared, plus 5. So we have 21 equals 2 squared, which is 4, so a times 4 plus 5. We'll bring that 5 over. We get 21 minus 5 equals a times 4. 16 is going to equal a times 4, and let's divide both sides by 4 to get that a by itself. We get 4 equals a. So what is the equation? The equation would be y equals, instead of a, we're going to have 4x squared plus 5. Perfect. Okay, we have Charlie's throwing the ball from the top of a mountain. The path of the ball is going to be represented by the relation right here. So it says, from what height was the ball hit from, or thrown from? So we have two methods available to us. Method 1, if you picture this graph, we know that this c value is also our y-intercept. It's the most useful point in our entire equation. So our equation is y equals ax squared plus bx plus c. This is our y-intercept here. So from what height was the ball hit from? Well, we know our y-intercept is going to be our starting value, because if we had this graph, it's going to look something probably like this. So what would be our starting point? Well, this is where Charlie threw it from. He threw it from our y-intercept. So our guess, I'm going to guess that this thing is going to be thrown from a height of 245. But we can check that with math. Why don't we just substitute 0 in for our time, and that'll tell us what we started at, because our time was at 0 when we start. So our h equals negative 5 t squared plus 245. We'll substitute 0 in for t, so negative 5 times 0 squared plus 245, and we get h equals 245. And that's exactly what we had here. Okay. Now it says how many seconds was the ball in the air before hitting the ground? And this is a bit of a tricky question if we don't have a graph on our hands, because we are going to need to factor. So how can we make that happen here? Well, let's take a look at our equation. H equals negative 5 t squared plus 245. Here we're in a little bit of desperation mode. We can only factor if we have, instead of negative 5 t squared, we would need t squared. We can't have anything here except a 1. So what can we do? Well, what we can do is we can actually factor out this negative 5, because there's a negative 5 here, and there's actually a negative 5 here. Just what happens when you take that 245, you need to divide it by negative 5 instead of positive 5 when you pull it out. So I'm going to take that negative 5, I'm going to factor that out. And when I factor out of my first term, this negative 5t squared, I'm going to factor out that negative 5, I'm going to be left with t squared over here. This positive 245, I've taken out this negative 5, which means that I've divided out my negative 5. So 245 divided by negative 5 is going to give me negative 49. And now, in here, I can factor this just like I factored this all the way up here. I said there is no middle term. So I'm going to need to find two numbers that multiply to negative 49, and two numbers that add up to our middle term, which is 0. So what two numbers multiply to 49? Well, 7 and 7, because they need to be the same because we have a 0 here. But one of them needs to be negative, so I'm going to make it negative 7. So we have negative 7 plus positive 7. So I'm going to get h equals negative 5, and then I'm going to have my two brackets. I'm going to have t minus 7 and t plus 7, just like it shows you here and there. Perfect. I think the only other thing I'd really like to talk about is guessing how narrow or how wide a parabola is just by looking at some of the equations. So how this works, if I have the formula y equals ax squared plus bx plus c representing my parabola, this is how I decide whether something is narrow or wide. The a value, and it's not a capital A, it's a lowercase a. If it is big, that means my parabola is narrow. And if it is small, like a decimal or a fraction, this thing is very wide. Keep that in mind because the very first question you run into in your homework is going to deal with this. So if, for instance, if I had y equals 3x squared plus 2x plus 1, and I had y equals 0.4x squared plus 2x plus 3, which one is more narrow? Well, you take a look just at our a value, this 3 here, and you say, well, that's bigger than this a value, which is 0.4. So if it's bigger, this one would be more narrow. And if it's smaller, like this one is, this one would be more wide. And that's how you kind of quickly take a glance and say, okay, I know this thing is more narrow, or I know this thing is more wide. So your homework today is going to extend some of these concepts. Some of the questions might be tricky, some of them might be easy. Make sure you take a look at the solution video for this because we got to make sure we're getting this before we move on to our next stuff, which is going to be a little more practice with this.